Okay, so good morning. Morning. So we're going to have a look at this, look at waveforms. You've probably seen all this, we've covered a lot of this before in the past. But you've got your standard waveform there. So y is your amplitude, the resulting height of your waveform. So this is your y-axis, over say time. It could be volts, it could be amps, it could be power, it could be just about anything really. So we're going to call it y. A is your amplitude, so how big the waveform gets. Remember, it's only, I'll draw it back again, it's only the peak part, that's your amplitude. If you remember our mains voltage, 240 volts, is an RMS value, and we actually have an amplitude of 339 volts at the amplitude. So that's the kind of thing. So you'd multiply. The sine function basically is a ratio finding function. So you get a ratio between +1 and -1. So that's what it does, and you multiply it by your amplitude and you actually get the height of the wave as it changes. So that's what's going on with the sine function. This is omega, Greek letter omega, t for time obviously. The omega is the angular frequency. So that's to do with how many times it revolves around, and that's linked to frequency, which we're going to have a look at shortly, because we're going to find the frequency. And this is supposed to be alpha. I know it looks like a fat fish, but it's supposed to be alpha. The first letter of the Greek alphabet. And this refers to the phase angle. It could be 0 though. Like this one ain't got a phase angle. Starts at 0. Okay? So it could be 0. So let's have a look at an example. So we've got this waveform here. So it's got an amplitude of 2.63 at its peak. I've answered the first question then actually. And you've got all this other information here. And to answer these questions, you can just, most of it you can just read straight off quite quickly. So the amplitude is, as I've just said, and give the game away, that one there, the amplitude's the bit in front. So the amplitude is 2.63. Nice and easy. So the next question is find the phase angle. And again, it's easy, you just read it off there. So the phase angle is that. So the phase is simply pi divided by 7. So that's quite easy. And then we've got the frequency. So we need a little bit of work.
I do apologise.
Don't worry about it. So now we need to find the frequency, we need to do a bit of work, and we're going to use the formula, this standard formula, omega equals 2 pi f. And you will have seen that before. You get that in your capacitor formula and your inductor formula, where you need, it's supposed to be angular frequency, but we need to convert it to a working frequency. So what I need to do is, let's have a look. So we've got our omega equals 200 pi t. Sorry, t is the variable of time. So the omega part of the formula there is 200 pi, which is the same as 2 pi f. So if I rearrange this part, I'll get that the frequency is going to equal 200 pi divided by 2 pi. So the pi's are cancelled, 2 goes into 200 100 times, so it's going to be 100 hertz. Okay, so it's as easy as that. So the last part is find the period, and that's simply this formula, 1 over frequency. You remember that formula, I trust? So I've got that cemented in. Obviously it works in reverse as well, but we're going to use this one. So we need, our period, capital T for period, is going to equal 1 over the frequency. Okay, which will give me 0.01 seconds. So that's how long it takes to do one cycle, complete cycle, before it starts again. So 0.01 seconds. Okay.